For my lab 5, I chose to analyze an object thrown upwards with some initial velocity. In this lab, I will first go over the physics principles behind it, then I will go over the procedure I used, I will then go over the code I used, then I will review the results and discuss. For the physics principles behind this lab, first of all, we have Newton's second law, where the net force is equal to the change in momentum over the change in time. And from this, we can derive the velocity update formula and the position update formula, which are given below. We will also be looking at kinetic energy and gravitational potential energy, and the equations for those are given. We will also be looking at the energy principle, which states that the total change in energy is equal to 0. In this case, the change in kinetic energy plus the change in gravitational potential energy will equal 0. Here is the procedure I used for this experiment. First, I recorded a video of a ball being thrown directly upwards. I then imported that video into Tracker and tracked its movement and produced a position versus time plot. Then I created a model in Python to model this motion using an estimated initial velocity from the data that I had. I then compared the model to the observed data. Also in my code, I calculated the kinetic energy and the gravitational potential energy, and I plotted these versus time, and then I analyzed how all of this relates to the energy principle. Here's my video running in Tracker. As you can see, I used a tape measure to calibrate the length. Here's my code in Python. At the top is the visualization for the ball, as well as the setup for the plots. Further down are the initializations for the mass of the ball, the initial position of the ball, and the initial velocity of the ball. Further down we have the while loop. We have the net force, which is equal to the acceleration of gravity times the mass of the ball. Then we have the velocity update formula and the position update formula, which were given before. We also have the equations for kinetic energy, which was given before, and the equation for gravitational potential energy, which was given before, and then the equation for total energy. Here's my code running. Below the visualization is the position versus time graph. Below this is the velocity versus time graph, and the slope of this line is equal to -9.8, which is the acceleration of gravity, and this makes sense because acceleration is the derivative of velocity. Below this we have the energy graphs. The blue line represents the kinetic energy, and the red line represents the gravitational potential energy, and the green line is the total change in energy. As you can see, the kinetic energy starts out positive and the gravitational potential starts out as 0. And right here, where the ball reaches its maximum height, the gravitational potential is at the max and the kinetic energy is 0, and then as it goes back down, the kinetic energy increases and the gravitational potential decreases. Here are the two position versus time plots. The blue points represent the recorded data in Tracker, and the orange line represents the data generated from my model. As you can see, they are pretty close. In conclusion, as mentioned before, we showed that the model satisfies the energy principle. Also, my model was very close to the observed data. My model did not account for air resistance, but I thought this was negligible since I used a golf ball for my object. This concludes my lab.